Today we are going to talk on the topic of semiconductor with my friends Manjit and Manu. First of all, what are semiconductors? Semiconductors are materials whose electrical properties lie between conductors and insulators. Example, silicon and germanium. There are two types of semiconductors, intrinsic and extrinsic. Intrinsic semiconductors consider nominally pure semiconductor at temperature 0 Kelvin. There is no electrons in the conduction band. At temperature greater than 0 Kelvin, a small fraction of electrons is thermally excited into the semiconduction band, leaving the same number of holes in the valence band. Now, the extrinsic semiconductors. Electrical properties of semiconductors can be altered drastically by adding minute amounts of suitable impurities to the pure crystals. Impurities. What are impurities? Atoms of the elements different from those forming solid. There are two types of impurities, interstitial and substitutional. Interstitial. Foreign atoms squeezed between regular sites, crystal sites. Substitutional. Foreign atoms occupying the sites of host atoms. Now, my friend Manjit will explain you on P-type and N-type semiconductors.
What are P-type and N-type? Semiconductors are classified in two types. P-type and N-type semiconductors. P-type. A P-type material is one in which the holes are majority carriers. N-type. N-type material is one in which the electrons are majority carriers. They are negatively charged. The highest energy band completely filled with electrons at T temperature is equal to 0 Kelvin is called the valence band. The next band is called conduction band. The energy difference between the bottom of the conduction band and the top of the valence band is called the band gap. Conduction. Electron conduction is easy to imagine. Electrons move almost like free particles. Hole conduction is due to positively charged particles in the valence band. False.
1. What are donors? We use silicon as an example. Substitute one silicon atom with a group 5 atoms. Silicon atoms have 4 valence electrons participating in covalent bonding. When a group 5 atom is placed in a silicon atom, it will use 4 of its electrons to form a covalent bonding. What happens with the remaining electron? Now, what are receptors? Use silicon as an example. Substitute one group 3 atom with a silicon atom. Silicon atoms have 4 valence electrons that participate in covalent bonding. When a group 3 atom replaces a silicon atom, it cannot complete a tetravalent bond scheme. An electronic equation is formed when electron from the valence band is grabbed by an atom so that the core is negatively charged and the hole is then attracted to the negative core. At temperature 0 Kelvin, this hole stays with atom, localized hole. At temperature greater than 0 Kelvin, electron from the neighboring silicon atom can jump into this hole. The hole can then migrate and contribute to the current. Semiconductors in summary. The most widely used material is silicon. Pure crystals are intrinsic semiconductors. Doped crystals are extrinsic semiconductors. And N-type semiconductors have few minority carriers called holes. P-type semiconductors have few minority carriers called electrons.
Pause.